Now we will see the effect of temperature on the microbial growth. As we touched this topic slightly earlier than this as well, temperature is an important growth condition for microorganisms. As we earlier discussed, that the minimum temperature at which we have seen the growth of microorganism is minus 34 degrees C, which is a very low temperature, and then the high temperature range at which we have observed the growth of microorganism is 90 degrees C, which is quite high. So that sees there's a very wide range of temperature in which different microbes can grow. As we earlier discussed, they are classified on the basis of temperature as whether psychrophiles or mesophiles or thermophile bacteria. So once we know that the pattern of growth of these microorganisms or the desirable temperature range, we can change the temperature of food accordingly so that we can produce the unfavorable condition for microorganisms in specific kind of foods, and we can stop or reduce their growth in food. If we talk about molds, they have got a different style, and they can grow at a wider range and different moisture condition, pH condition, and temperature conditions as well. They can grow at a wider range as compared to bacteria. So they can be growing at lower temperature as well as very high temperatures as compared to bacteria. So they are more adaptable to these temperature conditions. And as you might observe that molds are even there in the refrigerated foods as well. Most of the time, if we refrigerate food, the shelf life can be increased because the low temperature stops many of the bacterial growth in it, but the molds, they can still grow in food under the refrigerated conditions as well. Similarly, yeast normally doesn't grow in higher temperature, so we can avoid the growth of yeast high temperature, but they can be seen in the lower temperatures, such as the medium range temperature or the low range, like psychotrophic conditions. They actually favor the growth of yeast. So that is why we need to look at the optimum temperature range of a specific microorganism, whether it's a mold or yeast or bacteria, whether it's a pathogen or a spillage microorganisms. Once we know it, we can control and we can change the temperature in a way that we can make it less feasible for the microorganisms to grow. Again, we might be tempted to freeze all the food or refrigerate all the food. For example, the freezing temperature is minus 18. That would stop the growth of many of the microorganisms, and food can be actually stored for a very longer time at freezing temperatures. And same is true with the refrigeration as well. Like in case of refrigeration, we can increase a significant amount of time a food can have, a shelf life, it can have useful life. But again, all the foods are not suitable to be refrigerated or to be frozen. So we don't have this option for every kind of food, but certain foods can be stored at these two temperatures. Heat control methods to control the growth of microorganisms, we do use this phenomena very often, control the growth of microorganisms. For example, we apply high temperature in most of the cooking operations and some other techniques such as pasteurization, sterilization, ultra-high treatment. These are the kind of treatment that not only bring the desirable changes in food, neither they can only cook the food, but they also make it safer. They can reduce the incidence of many of the pathogens or disease that is related to food. So this is how we treat food actually to control the microorganisms. On the other spectrum of this temperature, if you go for the lower temperature, then we can have applications such as blast freezing or cryogenic freezing. These are the two techniques in which we drastically reduce the temperature of food to very low temperature that actually have a positive impact of many of the food to increase their shelf life. So once we go for cryogenic freezing, unlike the other freezing, we use liquid nitrogen or some other sources, and that would quickly freeze the food, and they would form smaller ice crystals that would not break the structure of these foods. So this food would be available for a longer time with good quality and the growth of microorganisms can be stopped. So this is the importance of temperature, to understand at which different microorganisms grow and how we can use this information to our maximum benefits.